All right, so everybody needs a calculator and you need your notes from yesterday. We're going to be on page 3. So, well, actually, I'm going to hop back to page 2 for a second, just to review. Remember we talked about P-Man? I'm recording, just so you know. So there was an acrostic I taught you yesterday, P-Man, and I said I like to add the DS to the end. So we said P stands for power to power. You multiply. When you multiply, you add. So those are the 2 rules we covered yesterday. Today we're going to cover the rest. We're going to start with quotient of powers. So when you see the word quotient, what do you think? What does quotient make you think? It's a key word for what? Yes, division. Will you please write that above quotient of powers at the top of your paper? Division. Okay, so this rule, we talked about what you do when you multiply, what you do when you have a power raised to another power. Now we're going to talk about what you do when you divide exponents. Okay. So let's look at the example here. We have 6 to the 9th divided by 6 to the 4th. All right. So what this really means is you have 9 sixes. I know it's tedious, but write those 9 sixes in. You're going to need to know. 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, it's a lot. 9 sixes and divided by 4 sixes. Okay, so those are our numbers here. Get your notes out and your calculator. All right, so in any time you have in a regular fraction, okay, if you have the same number on top as bottom, we say those cancel out. Like they cancel out because 6 divided by 6 is just 1. Okay. So what we can do, we can start canceling out pairs that we find. All right. So that takes care of 4 x's on the top. 4 sixes on the top and all the 6's on the bottom. But it leaves us with how many 6's on top? How many 6's do we have left? 5 6's. So we could say that the answer that we're left with is 6 to the 5th. There's 5 6's multiplied by each other. 6 raised to the 5th power. So write that in as your answer, because that's what we just figured out with the expanded form. Now, I want you to look at this answer and come back over here to the original expression. Do you see any correlation of how we could get this to here without having to do all this? A shortcut, if you will. Look at the numbers. Do you see any kind of pattern or any relationship between this and this? Yep, they still have that 6 base. That's good. What else? Look at the exponent. These exponents and then the final exponent. Yes. If you subtract the exponents, you get this exponent. So really, when you divide exponents, what do you end up doing to them? Subtracting them. Good. Okay. So let's do this again just to make, we got to write them all out because, it says expanded form. And there's not a lot there. Okay. We could see the same thing happens here. We go to cancel. Oh, we're left with 1/100. So 100 to the 1st power, but we don't put that. We don't put that little 1 there, but you could, is our answer. And that would make sense because 3 minus 2 is 1. Okay. Look at your next one. Man, it's a lot of T's. We can do it. T, T. 1, 2, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 t's over 11 t's. Yes, but it wants it in expanded form, and that's expanded form. So we're going to fill it in. All right, so we got, let's just pair them up. All right, so how many are you left with? 4 t's, t to the 4th. Makes sense. 15 minus 11 is 4. And it's the same. We're going to change the bottom right here to a 3. Go ahead and change that bottom to a 3. That was a misprint. Can you change that to a 3? X to the 3rd. Okay, so 4 x's on the top, 3 x's on the bottom. When you go to mark them out, you're left with 1x. So your answer is x. It's like x to the 1st, but really that just means x, which makes sense. 4 minus 3 is just x. Okay, now let's look down here. We could follow the same pattern with all of these down here, and it should be pretty easy. So again, our rule, as long as your bases are the same, which like they are here, the A is the same base here and here. You do what? When you divide exponents, what do you do with your powers? What do you do with them? Do you add them? When you divide, do you add exponents? Subtract. Thank you. So you subtract your exponents. So write that in. You would subtract m minus n. So let's do that down here. Okay, it says simplify the following expressions. Write the answer in exponential form. Exponential form means we don't have to solve it. We want to keep it in exponents. So 16 is our base. 7 minus 3 is? Yep. W is our base. 25 minus 10 is 15. 4 is our base. 17 minus 5 is 12. All right. Now, I'm going to cover up D, E, and F, and I want you to see if you can solve them by yourself, and I'll reveal my answers. And don't be afraid of that last one. Put what you think it is. This is not a grade. This is just for you to do on your own. Okay, so how did you do? Did you get the same things I got? Did you get 9 to the 0? Okay, well, in your calculator, go ahead and type 9 to the 0 in your calculator. 9 housetop, remember the housetop over the division? 9 housetop 0, enter. What does it tell you it is? 1. Okay, that's going to kind of lead us into our next rule in a little bit. But anything to the 0 power, anything to the 0 power, it could be x to the 0, 9 to the 0, 125,000 to the 0. Anything to the 0 power, if 0 is the exponent, the answer is 1. Okay, that's just a math thing. Because if you have you have 8 nines and then 8 nines down here, you cross them all out, they're all gone. But it's not 0 is your answer. There's still a fraction with a 1 on the top and a 1 on the bottom. It's just understood. It's 1. It's weird, I know, but just know that anything to the 0 power is 1. Okay, so let's look at number 1. This is combining all 3 rules we've learned thus far. So remember, P man, if there's multiplication right here, multiplication, we add. Multiplication, add exponents. So you keep the base. Add your exponents. Power to power, what do we do there? Y'all remember? Power to power. Power to power is P. Next is M. What does M stand for? Yep, multiply them. And then quotient division, what we just did, you what? Yep, you subtract it. Good. Okay, so do the same thing down here. Multiply, we add them together. Divide, we subtract. It's just regular 10. You don't have to put the 1 there. And then power to power is you multiply the powers. 5 to the 14. Okay. All right, now we have one more rule to learn, and it's broken into 2 parts. The first part is a little trickier. The second part, super, super easy, the easiest one ever. Okay, so let's do the hard first. You know, it's like whenever someone says you have good news and bad news, I always want the bad news first so I can end on good news. So the trickier part is this first part here. It's not tricky. It just seems like it is. So we're going to use our calculator and we're going to solve these. Let's do that. 2 raised to the 3rd power is 8. Go through and answer all these in your calculator. Even the negative, it's okay. You could put 2 to the negative 1 and it will give you an answer. Okay, so these up here, some of you might even know them off the top of your head. 2 times 2 times 2 is 8. 2 times 2 is 4. 2, of course, by itself is just 2. And then anything to the 0 power is 1. It was down here that you found out some new information when you have negative exponents, okay? What is the fraction form of 1/2? 1 over 2, right? What's the fraction form of 0.25? 1 over 4. Does anybody know the fraction of this one? Yes, y'all memorized these before in your math classes. That's awesome. 1 over 8, okay? All right. So look at these answers and look at these answers. Do you see a correlation between these answers, and the exponents in the problems? They're the same numbers, they're just where? They're, well, different order, yes. They're in a fraction, they're underneath a 1, okay? So whenever you have a negative exponent, like right here, this negative n, any number that's a negative exponent or a negative power, you just put that under 1 and take off the negative sign. So like 2 to the negative 1 would be the same as 1 over 2 to the 1, positive 1, which we know is just 2. 2 to the negative 2 is the same as 2 to the positive 2, which is 1 over 4. See? 2 to the negative 3 is the same as 1 over 2 to the 3rd, which is the same as 1 over 8, because 2 to the 3rd is 8. All right. So let's go through. Oh, before we do that, the other part of this rule, super easy, is the 0 part. What did I tell you? Anything to a 0 power is what? 1. 1, 1, 1. Always 1. Always, always 1. As long as it's not 0 to the 0, you can't do that. If you put it in your calculator, it'll say error. There's no such thing as 0 to the 0 power. So right now on your the problems on the bottom, anytime you see a zero exponent or zero power, go ahead and answer those as 1. See if you can find all of them. Okay, I think that's it. And now we can go and solve the rest of them with those negative exponents. So let's start with B. 2 to the negative 4. Well, I told you put it always under a 1. If it's negative, put it under a 1 and make the exponent positive. 1 over 2 to the positive 4. And it says leave it in exponential form, so we're not going to solve it. But if we wanted to, we could see what 2 to the 4th was, which is 16. And it would be 1 over 16. But we can leave it in this exponential form. That's fine. So D, 1 over 5 to the 3rd. That's it. On D, it's a negative exponent. So our rule says when we have a negative exponent, we make the exponent positive and put it underneath a 1 in a fraction. So on E, it's 1 over 10 to the positive 2. You see that pattern? Okay. So look at G, H, and I. Those are a little different because they're fractions. Okay. And this seems hard at first, but really it's super easy. There's 2 steps here. The first step is that you have to know that when you have a fraction, the exponent goes to both the numerator and the denominator. So I like to rewrite it like this. 1 to the negative 2 over 4 to the negative 2. Because that negative 2, it attaches itself. It's like it distributes it to the numerator and the denominator. So rewrite this fraction to say 1 to the negative 2 and 4 to the negative 2. Okay, but we can't keep, an answer cannot have a negative exponent. It's not proper. There's one more step we have to do. So you know how down here, up here, when you had a negative exponent, you would just put, like we would put 1 over 1 to the 2nd, make it positive. Well, you can't do that because there's something down there already. So you move it to the bottom, but you have to do something with this, what's on the bottom already. You have to do something with this 4 to the negative 2. To make it positive, you actually move it to the top. So it's like it flips. So this becomes 4 to the 2nd, and this becomes 1 to the 2nd. And when you flip them, it takes off the negative sign. So if there's ever a fraction, you flip it. Okay. So we're going to keep it in this form because it says it wants it in exponential form. But really, you could solve this. This is 4 squared is 16. And 1 times anything, 1 times itself is 1. 16 over 1. It's just 16 is the answer. But we'll leave it like this. So look at H. You have a 1 to the negative 2 and an x to the negative 2, because that negative 2 is the exponent for both the numerator and the denominator. And then we flip it. We end up with x squared over 1 squared. And the last one is 1 to the negative 9 over a to the negative 9. What do we do to make it nice? We can't leave it as negatives. What do we do with it since it's in a fraction? What did I tell you to do on the rest of these? Flip it. Yep. So you have a to the 9 over 1 to the 9. Yes, I made my a look weird because it was getting me confused earlier between what the a and the 9 looked alike. Okay, so on the U try section, see if you can look up here to how we did these and try to figure out how to solve these. Remember, it's only in a when it's in a fraction form do you flip it. Other than that, you just put it 1 over that same thing, just make the exponent positive. I'm going to cover up my answers. All right, when you're ready, go ahead and see how you did. Please let me know if you have questions. Okay. Is everybody good on this? That last one's the only one that's tricky with the fractions. So let's go back to before we end. Let's go back to our P-man DS. Okay. And fill in the rest of our acrostic. All right. So everybody go back to where we wrote this acrostic. So just a reminder, the P was power to power, and that told us the next letter tells us what to do. We multiply. If we have exponents that are multiplied, the next letter tells us what to do, add. Well, we're going to keep in that theme. If you have exponents that are added together, you actually do not do anything. You do nothing to them. We don't add exponents. Okay, we didn't do any problems like that, but that's why. They wouldn't change. It would just be the same. Okay, now I add this DS part. It doesn't have anything to do with this N. It's not connected to the N. But it is an important part that helps me remember those last rules. Yep. If it's like, if you're dividing, then you subtract your exponents. Okay. If you are dividing exponents, then you subtract your exponents. And that's it. Okay. Tomorrow we're going to use these notes to go over a worksheet, or we're going to do a worksheet in class and grade it at the end of class. So make sure you're good on this. There's no homework tonight, no video tonight. Your first video that you need to do for homework will be tomorrow night. Okay, and that's it.